Data structures. Introducing list from a problem solving perspective. This video is going to be the first of couple of videos where I discuss various kinds of data structures which are basically collecting and in parallel allowing to operate on individual objects. So what happens is, till the last video, if you have been following this series on Python related introduction and problem solving perspective videos, you would have seen that I introduced objects and how to move from procedural to functional to object oriented programming. Now, after we created objects, what we do with it? So this particular discussion, we are going to work on that. Once you have object, there are going to be lots of objects that you are going to assign to variables. Like you can actually create integer objects, string objects, you can create list objects, and various kinds of other objects like dictionary, pictures. There are so many. All the data can be made into objects, right? But why we have to collect it, and how lists are going to help us in doing that? Let's scroll down. First of all, when you are going to work on a particular problem or any kind of a challenge, there is going to be a lot of different factors that are going to be involved in the problem. And there are certain factors that actually keep changing. There are certain factors that are random and then start updating time to time. All these factors we might want to collect, and lists are one of the most basic way of collecting multiple objects of same or different types, objects of different types. This is very important. You can have both a list of integer, and also inside the integer you can have strings also. So it can have a heterogeneous type of objects inside the list. So list is kind of a very flexible operating data structure. Why we call it as a data structure? So that is something that we are going to see next. So list is basically, it looks like this. So list is just a container with, in this case, lot of circles. And we can actually do a lot of things with it. We can collect the individual objects. So I have created circles and I have collected it here, and we can actually operate on individual circles. We can actually change the color, we can make the size of the circle bigger, we can do a lot of steps, and still it will be part of the list, right? And you can see here we can actually do the same thing. So what you're going to do is, in continuing with the earlier video where I introduced the turtles, where you are going to draw the rectangles, we are going to continue in that with that particular object that we created in the last video, the rectangle object. We are going to use it inside the list. We are going to create a list of rectangle objects using list comprehension. You will see that in action in a couple of minutes, and then we will first of all execute it. You will see the rectangles come up, and then you can do a lot of stuff there. So let us jump into the code. So we have the code here, and what I have done basically is that I have kept the same RectangleTurtle class that I created in the earlier video. Nothing has been modified. I have also added a bit of information here. I had added hide turtle, and I had added a new method called as destroy self. So there is a draw self method and there is a destroy self method. You will be seeing this in action after a couple of minutes once I complete the basic demo. And then we have the give dims and locate home. All these methods are already there. Only difference is this time it is going to write directly on the turtle screen itself. It's going to be visible on the screen where the rectangles are drawn. And finally, I am doing the main activities here. So first and foremost, let us complete the demo. The script is present in this particular directory. The GitHub repo of this particular directory will be shared to you in the link. You can take a look at it there. And the file that you're going to use is datastructure_list.py. So with the underscore instead of spaces. Now I'm going to execute this. So I'm going to say Python datastructure_list.py, and I'm going to execute it, and it will ask me for pressing enter to start the to get the turtle window in the view. I have done that, and I'm going to press enter. So once I do that, you'll see that the rectangles are getting drawn right now. And you can see that I'm not doing anything and it is doing by itself. And the rectangle, all the rectangles have been drawn. The rectangle sizes are also mentioned here in the middle of the rectangle. You can see that here. And the rectangles are looking haphazard. If we go back to the presentation that we are having, if you look at this particular picture. So here what we have discussed is that we can collect a list of objects, right? We can collect a list of objects inside the list, and then you can operate on it, right? And also you can modify that. So now what you're going to do is, in this case of structured data list, what I've done is, you saw that it created 4 rectangles. So what was the background for this? How these 4 rectangles were created? After we press enter to bring the turtle window into the view, we are first of all modifying the size of the screen using t.setup, and then we are creating lists here. This list is made of numbers. So both the lists are made of integers, both positive and negative integers are included. This list is going to be used in creating the rectangles. How it is going to be used? So as I already explained, list is a collection of things. In this case, it's integers, and then I'm going to create an empty list. So this is a very common method of working with in problem solving. So you will always have some kind of a list which collects the data and stores it for you to process it. You can actually store it for returning the data from a function. A lot of places lists is like a pretty common one of the most important data structure inside Python and most of the programming languages also. Next, what you're going to do is, we are going to use a method. So every object, so list is also an object. Once you use this particular symbol and you instantiate a list, it will get itself a lot of methods. The methods like locate home, give dims. So like this, list has a lot of methods. So for an example, if I say list and if I press the dot in the press the full stop in the VS Code, what will happen is it will show me all the methods that are available for this particular list object. So you can see that there are other ways to get the list object methods, but in VS Code it's pretty straightforward. So there is a command called as dir inside Python, ideally, that you can use to get this same output that you're seeing here. In fact, the VS Code backend will have done the same thing. Okay, now you see that there is append, clear, count, all these options, all these methods are there. If you choose any of the options, say if I choose count and if I execute it, it will simply say, okay, just in case of self, give a list, and in case of value, you don't need to give anything. So once you give this particular, you call this count on a list. So if I call this on a list, so here in our case, we have 2 lists. We have X list and Y list. So if I do a count on this, so you will immediately get the count of number of elements in the list. Like this, you can also do a couple of more things. You can actually do appending. So once you start appending, you can actually append additional elements to this list. Okay, this particular discussion, I am not going to talk to you about what you can do with the list. Okay, the idea here is a little bit different. See, there are lots of videos, there are lots of documentation, but my intention here is that I want you to get an idea of how to look for stuff, right? Most of the time what happens is, in case of Python, there are lots of abstractions, meaning I have created this particular list, and the list is instantiated using 4 different numbers, or it can be instantiated with any of the data types. But the idea here is that what are the methods that this particular list can have? So how will you find it out? That is the question that you need to think about. So everything inside a programming language like Python or Go or whichever language you like have a purpose, right? They are not written for sake of fun. So it is created for a particular activity. Sometimes it is just one activity or one purpose, and most of the time it is more than one activity. and these activities are grouped or are actually implemented using methods. So that is the first thing that you need to understand when you are coming across a new object. Like in case of the rectangle object, as already I told, there are 4 methods: draw self, destroy self, give dims, and locate home. These are the 4 different methods. Like this list will have a lot. So when you are going to create a data structure, or when you are going to create an object of your own purpose, then you need to ensure that what kind of methods are there, how you are going to give the doc strings, provide the help for the users. All these things you need to think. This is one of the important aspect that I wanted to share. It's not just that you try to understand and solve the problems. It's like you should be able to solve the problem, then you should be able to document it, then you should be able to share it with others, and they use it and get benefited. So all these steps we need to think about, right? So my intention here is to show you the basics of list, but I would like you to explore further. There are lots of tutorials, but the idea here is that you need to understand this intuition. You can have anything inside the list, including the RectangleTurtle object that we initiated here. So what this means, if you also create a class, write a class, then you can also put that class inside the list, and you can do operations on that list of your own class. This is what I want you to take home from this discussion. So now here I have used a for loop. If you guys are following these videos, you must be already knowing that I introduced the for loop. I also introduced the logic, I introduced the variables, inputs, all those stuff in the beginning, and I am slowly building it up, because learning it this way provides a huge amount of clarity on how you can use it later. So because you are solving small problems here, which is very creative in nature, it's not a regular cookbook or any kind of a thing. This is something that I thought of to create, and I started working on that. So I wanted to create a program that prints rectangles. You might want to create a program that prints something else or writes something else. You might want to use some other library or whatever it is. However, how to do these things as easily and as fast as possible. These are the points that you need to continuously think about. So we are using append method here to append the rectangle turtle that we are creating, and we are doing this using enumerating the X list. So we are enumerating the X list, but we are doing it and getting the index values also. So both of these things we are getting, and when we get the index value, we can use that index value to get the Y value. So Y list, if you are going to use the Y list, you can give the index value that you are getting from X. So this particular line I would like you to explore. So what I would suggest is that you try to give a print statement like this and try to see what is the output that is coming in index IND and X. You need to look at it. This is how you have to understand what is going on inside the code. The more you look at the data, how it is processing, you can intuitively understand. Yes, it is good that you see the videos, you read the documentation, no doubt, and yet looking at the data, seeing what happens actually helps you to recollect fast. And when someone is going to challenge you with a question, you will know exactly how the interpreter or Python works at the backend, right? So that is one thing. I'm not going to show you this. And second thing that I want you to notice is that I have actually put comments here. So each and every location I am placing the comments, and I am also showing some examples there. And finally, if in certain cases I'm telling what the next line is going to do. So in this case, enumerate the list of coordinates and append to the rect list. So I am enumerating these two lists, and once I enumerate it, I'll be getting both 20 and 10 as the X and Y. So that is how I'll get it. So using these two constructs here. So 20 and 10, so 10 X will be 10 and Y will be 20, 55, 60, minus 115, 125, minus 210, 210. So all these things I will get in this location, and I will build the rectangle turtles. And once the rectangle turtles are built and I am putting them into rect list, then I can draw each of the rectangles. So, and then I can ask them to give the dimensions also. And finally, when I click on this particular window, the window will close. So that is how the exit on click works, and it keeps on running in the main loop. That is how the code works. But the point is not the code, or the point is not even the execution that you saw right now. The point I wanted to make is that how you play with it. Just a second. Okay, it errored out because I did not append anything to the list. And let me start again. Let me open the command prompt. So here the issue that I wanted to highlight is that it is not just that I want to show you how the animation works. It's more like what we can do to change these rectangles and play with it even though it is inside the list. So that is what we are going to see. So let me click this, it will come out of it. And now I am going to go into IPython. We are going to import. So we are going to import from Datastructures list from import. I'm going to import RectangleTurtle. And I am also going to create a rectangle list. So in this case, I need to first of all have the X coordinate, and I need to have the Y coordinates also. So all these things I have already created it, and using the IPython I can recover the history, whatever I have done. So that is how I am able to get these things all done in a much faster rate. That is also one of the reason why I use this IPython. And after I instantiate both X list and Y list, I am going to create this rectangle list. The same thing that you see here that I have done using the for, I have done it using the list comprehension here. I will dive into list comprehension separately in a different video. However, this is one of the examples where you can use two variables. So I am using both X and Y, and this X and Y is coming from the zip X Y list, X and Y list. So that is how it is coming, and I'm going to create it. The moment I create it, what happens is, the moment I created, the turtle window opens up. So you can see that turtle window opens up, and I am going to keep it open right now for our visibility. Now this rec list, so if you do a length on rec list, so you'll see there are four elements in this rec list, and each of the element we can access separately. So if I say if I just press enter, so you will see there is 4 data structures, and in the data structures you can also see that it is written as RectangleTurtle at this particular memory. All these memory locations are different. So basically objects are stored inside the registers in the RAM. That is how it works, and whenever you are doing some operation, it goes to that register, and whatever methods or whatever code is there, it will execute. What we are going to do is we are going to only work with one rectangle right now. We are not going to work with all the rectangles. So I'm going to work with the second rectangle, and I'm going to ask it to draw the self. So once I execute it, you will see it is drawing only the second rectangle. And if I say destroy self, so if I do this, if I say destroy self, that rectangle will get destroyed. Now you see how the control is happening, and these controls are written using this kind of methods that we already saw. These methods are written by us. It just takes 1 or 2 lines. That is the power of it. And once you understand the logic, you can actually change. Once you are familiar with the Python background of Turtle and the various methods Turtle offers, which I already discussed in the earlier videos, you will be able to build up such kind of code very, very fast. And you can learn about object-oriented programming so well using Turtle that, believe me, that is where I got the idea of this, even this particular what is it called, visualization, that you can actually create a list of rectangles, and the list of rectangles can be separately modified. So we saw that we can destroy and create the rectangle list, each rectangle. We are going to modify the rectangle 2. So for modifying the rectangle 2, we have to create a new rectangle, right? So for creating the new rectangle, what we are going to do is we are going to modify the X coordinate and Y coordinate. So here what we are going to do is we are going to go to rect list 2. So instead of, so that in case of list there will be indexes, right? So there are 4 data structure rectangle turtles in this particular list, and the first rectangle turtle is 0, second is 1, third is 2, and final one is -1. So that is how list works. As I already told you, my intention is mostly to discuss about how to think about list as a data structure problem solving tool. The tool itself, how to use it, I'm not going to delve in this, right? The idea here is that once you understand what the list has to do, or what you think that list should do, this is one of the key aspect of intuition. You have to first of all think, if I'm going to have a list has to be, it has to be able to extend itself, it has to grow, and it has to also reduce in size. Second, it needs to have multiple types of items. It needs to have, we need to be able to print it, we need to be able to get the length of it. Like this, you might have a lot of intuitions, and then once you have the intuition, then you go and check. Okay, so this is how you get the list method, which gives you the length, which gives you the makes you to print, and a lot of stuff like that, right? Let's now, what we are going to do is we are going to change the rectangle list to. So in our cases, the second rectangle, so 0, 1, 2. So the second rectangle was created at -115 and 125 height. So that is where it was created, and we destroyed it just now. What we're going to do now is we are going to create the same rectangle at a different coordinates, and also we are going to change the length of the rectangles. So we are going to say the breadth is going, length and breadth of the rectangle. So we are going to say breadth is going to be 250 and the length is going to be 150. And the x coordinate and y coordinate, we are going to keep it as 30 and 68. So I am going to press enter, and nothing happens. The reason is we need to make again the rectangle to draw itself, but this time you will see that it is drawing in a different location. Last time it drew here. You can actually reverse the video and see that it drew here. Now it drew here with a different kind of a output, and you can actually ask more information also. You can say locate self, locate home, and it will locate the home. You saw that it located the home here. The idea is that we are able to control each of the rectangles like that you are seeing here. We can control it separately also, and we can change the size, we can destroy the rectangle and redraw it. In fact, when we are going to when we are working on this rectangle, and if you are going to change the rectangle, so let me right now change the rectangle again, and I'm going to modify the rectangle coordinates. I'm going to increase the rectangle to 350 length and 550 breadth, and I'm going to leave rest of the things same, and I'm going to again redraw. Okay, I'm going to draw the self, and you see that it is drawing. So it is going out and it is drawing, it is out of the screen here. But you saw that this particular earlier rectangle was not destroyed. So now that is where the challenge happens. So before you, if you right now say destroy self, it will destroy the bigger rectangle, because you have completely lost the connection between the rectangle that you created here, that is a 250 cross 150 mm rectangle which is sitting here. You cannot have control back of this particular rectangle, right? Because in that location, whatever object was sitting, you had overwritten with a new object. This is a very different kind of thought process, that what happens when you are actually dealing with the objects and classes that you created by yourself. So you can actually experiment this with Turtle, and you can see it visually. The reason why I'm going into this route is to show you that in case if you are working on a problem and if you are trying to manipulate the lists, so what happens is you will be in situations where you will have to overwrite the list elements, like how I did right now. So I overwrote the element 2 with a new object, new data, 550 cross 350. The earlier one was 250 cross 150. So I had modified that. But if I did not destroy it, then what will happen is the earlier connection will be lost. So when we are actually writing the code, what I do is we have to destroy the self. So if you scroll down here, before I draw the self, we have to destroy it. So we have to add that point into into drawing self also. So I have to call destroy self before I draw self. So here what will happen? So if I draw it twice, the drawing will happen twice. So take a look at that. And let me bring it to the view. I'm going to press it enter and I'm going to bring it to the view. It is right now drawing. It is drawing all the rectangles that we are creating. Now you see something different happening. The earlier rectangle is still there, and on top of it, further rectangles are getting drawn. So this will keep on continuing. And all the rectangles have been drawn and additional rectangles have been also drawn. So the earlier rectangles did not get destroyed. So because of this, when I call the draw self, additional rectangles got redrawn again. So you have to have a way to destroy the rectangles before you start it. So if I do rectlist and rectlist index and I say destroy the self, destroy self, and now if I execute it, what will happen is it will destroy it. So you see here that we can operate on individual as well as the collective elements, but internally we are still working on individual elements only. We are using the for loop, or here I use for loop. You can use while loop, you can use other logic also. I'm zooming in a bit, other logic also, and then you can connect. So there is not, then you can update. So these are the ways you can work with it. So if I go and execute it right now, so I'm going to re-execute it. I have added the destroy self. I'm going to press enter, and then you'll see that it is drawing right now and it is also destroying. So it is destroying also. So you see that both the things are happening. So, and also you see that only couple of rectangles are destroyed and not all the rectangles are destroyed. Why is that? So these kinds of questions keeps on arising. And when your logic is not proper, these kinds of discrepancies will happen when you are working in much more complex setup. So one of the ideas of introducing list in this particular discussion is that you can use it first of all to store objects of any kind. That is the first thing that I want you to take a look and understand. And next thing is that you can use it to enumerate on top of the elements that are inside the list. And list itself has methods, and the element inside the list also will have its own methods. These are the things that you need to keep in your mind. And it is way more easier when you think about all the objects in the form of data plus their methods or the activity that you can do on the data. So when you have these kinds of perspective, and once you approach list from the problem solving perspective, because you are solving problem here, you have an object, you want to operate on it, you want to solve a problem using that object, and then you have to update it, right? You have to update it, or you have to return it to someone or show it to someone, like how I did. So I believe that in this discussion we understood the list from the perspective of problem solving. We collected a couple of objects, we started placing them in the list, and we operated on them by modifying the dimensions. We also destroyed the entire rectangles and we created it. And the same thing you can do it in real world also, once you are able to connect Python with various other primitives like databases, or it could be even AI models. It could be any other kind of constructs that you are creating with your own creativity, like the objects that you have created. So I believe with this video you have got a good idea on list. And till the next video, I would like you to practice on creating lists like this and also comment it out. With that said, have a great time, guys. See you.